Alright, next up on our list of triangle centers is what we call the incenter, and this one may give you a feeling of deja vu, particularly if you just watched the circumcenter video. So here's what I want you to imagine doing. Again, we're going to draw a circle, but this time instead of drawing a circle on the outside of the triangle, let's draw a circle on the inside of the triangle. And once you've got this circle in your mind, what I want you to do is I want you to expand it. I want you to grow that circle until it's as big as it could possibly be, and if it got any bigger, it would be on the outside of the triangle. So that would be a situation that probably looks something like this. Here we say that the circle is inscribed within the triangle. And what we're looking at here is, again, just like we did with the circumcenter, the center of this triangle, which is that point right there. And we say that that point right there, the center of the inscribed circle, is what we call the incenter of a triangle. And just like with the circumcenter, we can discuss the incenter in terms of particular lines that are meeting. So let's clear all this out and let's just have a look at our triangle and our inscribed circle again. If we were to take this thing and draw an angle bisector this time. So now we have an angle bisector of this top angle. Angle bisector just means it cuts this angle perfectly in half. And just draw that line and continue it on through. And then we do this for the other angles in the triangle. So now we get a second angle bisector. We bisected that one. And a third angle bisector. Just to make things easy, I've used an equilateral triangle here, so all those angles are in fact congruent. And what you can see is that for this triangle, and indeed for any other, the angle bisectors are going to be concurrent at a certain point. That is, they're all going to run into each other. And this point where they all run into each other, as you can see, is the center of that circle inscribed within the triangle. So we can talk about now our incenter being the point of concurrency for the angle bisectors of a triangle. So if you're trying to draw this with a compass and a straight edge, all you have to do is construct the angle bisectors of the three angles of the triangle, and where they meet will be your incenter. Now, as far as properties of this goes, you'll remember with the circumcenter we could use that to determine whether the triangle was acute, right, or obtuse. We don't have any tricks like that for the incenter, and in fact, I can tell you this about the incenter, that it will always be within the interior of the triangle. So unlike the circumcenter, the incenter will always be on the inside, which if you stop and think about what it means, kind of makes sense. Try and put that together for yourself if you haven't already. But the incenter will always be somewhere on the inside of the triangle, and it is the point that is the center of the inscribed circle, and it's also the point where the angle bisectors meet.